Okay, good afternoon, class 2 Alpha. Can you hear my voice?
Can.
Okay, thank you, Liao Ying Tung. Okay, and then number 2, can you able to see my presentation, my display?
Can.
Can also, yeah? Okay, very good. Right. So good afternoon, and to all of 2 Alpha, and then welcome. Who are you? Okay, please join us. And I hope you're all in a good condition. Uh, Always stay safe. Always what we call stay healthy, and then take care of yourself and your family. Yeah. Okay. And then number 2, if you watch the news yesterday about the reopening of the school, it is postponed. The original schedule, the original plan for the reopening of the school is on the 1st September, right? Last time, 1st September, right?
Yes.
Yes.
Yeah. Okay. And then yesterday announcement by the minister, Minister of Education, the reopening of the school will postpone until, anybody know? October, right? Okay. Until 3rd October 2021. So according to my calendar over here, okay, want to show you just to show you my calendar only lah, yeah. What happened? CAL. Okay, calendar. All right. According to my calendar over here, today is 16th of August. So we have another 1, 2, 3, and then 4, 5, 6, 7. 7 weeks to go. We are going to learn from home. I'm going to be teaching from home for another 7 weeks. Minus 1 week lah. Minus 1 week for the school holiday. Okay. On September, we have 1 week of school holiday starting from 11th of September to 19th of September 2021. So it is about 6 weeks more from now until 3rd of October 2021. We are going to be learning online. 6 weeks, about 2 months, right? Excuse me, sorry. So this is the situation right now because of the pandemic, because of the new cases that rise every day, including at our place, Sungai Siput. Also increase in positive cases of COVID. Okay, and then there also depends on the immunization, depend on how many people already take the vaccine, the complete dose, the first dose and the second dose, okay, for vaccine. For the adult population, what's meaning by adult population? Maybe 18 years and above. Okay, not including you lah, because you are not what we call not eligible to get the vaccine yet. Maybe 18 years old and above, adult population. If the people, if the adult population in Malaysia is already taking the complete dose, maybe at least first dose lah, so maybe we can government will consider reopening of school early than that. Okay, how about your parents? Your parents already take the vaccine? Anybody?
Yes.
Very good. Complete vaccine or no? Complete, yeah. Make sure your okay. Good. Very good. Make sure your parents and your older brother or sister take the complete vaccine in order to give us some protection lah. You still remember chapter 4? We learned about the human health, the importance of vaccine. Yeah, it is not. The aim of the vaccine is not just to stop the virus. Okay. The COVID vaccine right now, if we take the vaccine, okay, maybe the chances that we have severe symptom will greatly reduce. So there is no hospitalization. There is no people in ICU. Okay, the people still get positive, but with minor or very little symptom. Maybe just you got a little fever, a little what we call cough, and then Mainly, if you take Panadol and then your body can fight itself, and then you can only stay at home. That's all. We want to prevent mortality. You know, mortality meaning that we want to prevent the number of deaths. Okay, right now it's about 300, 200 deaths per day. Okay, and it is very worrying. So we must take the vaccine, the adult, what we call the adult population. Okay, for you, 14 years old, 13 years old, there is no decision yet by the government whether they want to inoculate you or no. They want to give you shot of vaccine for the school children. I don't know yet. Okay, but they want to take Form 4, maybe Form 5 and Form 6 before they come to the school, because they want to have examination maybe next year. They need to take the vaccine. Okay, this is the situation right now, and then it is not what we call we must expect the worst to come lah. Hey, do you know that the hospital Sungai Siput is already closed for outpatient? Sungai Siput Hospital is already become COVID hospital. Do you know that?
I don't know.
Okay. Just want to tell you, Sungai Siput Hospital has already become COVID hospital. They are receiving patient, a COVID patient. Okay. So if you want to go to the hospital for appointment, if you have a fever, you want to go to the hospital to see the doctor, you need to go others clinic, not at hospital Sungai Siput, because already closed, because they want to treat the COVID patient. Okay. That's the situation right now in Sungai Siput. Also, the cases is very, very high. All right. According to the Kuala Kangsar district, Sungai Siput, one of the area that has a very high positive cases. Orang asli lah, kebanyakan je orang asli. Daripada mana? Bawang sana, the post one. I don't know how come the COVID can go there very, very far inland, the orang asli place. Okay. Right. Never mind. So that is number one. I just want to just talk a bit for you before we start the discussion for today. And then number two, okay. How about the yesterday that I already gave you last week? This one, I need you to finish this on Wednesday, right? Wednesday. Okay. Any question about this exercise? Extra exercise that I gave you? Effects of force 8.2. You already done this. You already finished, and then put the finished question on the Padlet.
Yes.
Okay, if you're okay, very good. Do you want to never mind. I won't discuss the answer, but later on after the class, I will give you the answer directly without discussion. Okay, can I will give you the answer after the class. All right? No mind. Okay. So let us continue with the lesson today. So we stop at buoyant force. I think we already learned. We already what we call start. What is the buoyant force? Okay, and then the what we call the formula for buoyant force. Okay, the formula for buoyant force: actual weight minus apparent weight. Okay, for example here, okay, if you look at the picture here, if you look at the picture here, all right. So there is two weight. In order to what we call get the buoyant force, you must measure the actual weight, and then you must minus the apparent weight. So what is the actual weight? For example, the picture on the left, you try to get the force for the glass bottle, for the glass bottle. All right, outside the container. Okay. Okay, for example, this one. So in order to get the buoyant force, First, you must take the measure outside. Okay, this is the glass bottle that we want to test what is the buoyant force. Attach it with the string, and then by using a spring balance, you take the what we call the measure of the weight of this glass bottle outside. This is number one. So this is, you want to take the actual what? Actual weight. Okay, actual weight. All right. This is the first step. And then the second step, you put the water, you put the glass bottle attached to the spring balance, and then you put inside the water. So what will happen actually to the weight of the glass bottle over here? What will happen, you think? The weight increase or the weight decrease?
Increase.
Okay, again, increase or decrease? Number one or number two? The weight. The weight in when you put the glass bottle, for example, here the picture, when you put inside the water, what happened to the measure? What happened to the spring balance? The weight increase or decrease? Hello?
Increase.
Increase the weight. Sure or not? Okay. Okay. If you put the glass lid here, okay, I just give you maybe I just for example the actual weight. Number one, the process number one, step number one, you measure the glass bottle over here, and then the glass bottle is measured about 10 Newton. Okay, and then step number two, you put the glass bottle lid attached to the spring balance, and then you put in the water. What actually happened? All right, usually because of the buoyant force of the water itself, because of the buoyant force of the water, usually the spring balance reading will become decrease, will become lower. So this is what we call an apparent weight. This is now when you put the glass bottle, when you put the glass bottle in underwater, inside the water, so this is what we call by the apparent weight. And then usually apparent weight is less than actual weight. For example, here I just give you the figure only. I just give you an example only. What are the apparent weight for the glass lid over here? So it is about 9 Newton. Okay, but depend on the weight, depend on the object lah. If the object is heavier, so you get the different reading. This is just example only. So actual weight is 10 Newton, and then when you put the object inside the water, because of the buoyant force exerting upwards, so we can see that the apparent weight shown by the spring balance at step number 2 will become 9 Newton. Okay, so according to the formula, buoyant force is equal to actual weight minus apparent weight. Okay, so if the actual weight is 10 Newton, and then the apparent weight is 9 Newton, so what is the buoyant force? What is the weight of the buoyant force?
1 Newton.
1 Newton. Very good. So there is 1 Newton exerting the force upward. Okay, this is how you find out what is the buoyant force by what we call deducting actual weight. Okay, deduct with the apparent weight. All right, can you understand this? So you have the what we call apparent weight here. Okay. What happened? Okay. If others object, for example, according to the, so according to this one, all right. This also lah, yeah. This also lah, the same, the exercise here also, same lah, right? So how we can determine buoyant force and object? By using a spring balance, right? By using a spring balance. Okay, by using the spring balance over here. All right, okay. So actual weight of the rock is how many, class? According to the question here, actual weight is 0.65. Okay, and then apparent weight is the weight of the rock when it's submerged in water. And when you put the rock in the water, so it will become apparent weight. So apparent weight here is about 0.50 Newton. So the buoyant force of the rock is 0.65 minus by 50 is 0.5 Newton. Right, you understand this? Do you know how to determine the buoyant force of an object? By using this method. Okay, right. Can I continue? You have any question? Is it okay?
Okay.
Okay, very good. So this is spring balance. 0.65 Newton, and then the apparent is 0.50 Newton, and then you just write the transfer the value here. Apparent weight 0.50 Newton, so it will become 0.15. Okay, 0.5. Yeah. Ayo. And here, pen is not very good. Where is it? 0.15. Yeah, 0.15 Newton. So this is the buoyant force of the rock, right? Okay, next one. Okay, actually this is an experiment we need to do in the class, but never mind. Later on, very hard to, I just give you the theory side only lah, there are, maybe we can try to find out the buoyant force of many type of object. For example, glass bottle, rubber stopper, squash ball, and plasticine, but never mind. I just want to give you the what we call the theory behind it only. Practical side maybe later. Yeah. Okay. So density and buoyant force effects. Okay, you still remember what is the formula of density? Density, the unit is gram per centimeter cube, equal to the mass over volume. In Form 1, you already learned about density. Okay. And then meaning that if there is more density, all right, meaning that the object will float or will sink. The density of water. Before that, what is the density of water? What is the density of water? You still remember? Water density is 1 gram per centimeter cubic. 1 gram per centimeter cubic. So this is the water density. All right. If the object more than 1, the object is more than 1 gram per centimeter cubic, so the object will sink in the water. But if the object is less than 1 gram per centimeter cubic, the object will float on the water. Okay, So what is the relationship between the density and the buoyant force of the water? Like this. Okay. When an object is less dense than a liquid, is pushed into liquid, the buoyant force, upthrust force, or F, is more than the weight. Okay, it pushes the object up the surface of the liquid, the object will float. Okay, the object will float. This is what we call the relationship lah, between what? Between the density and the buoyant force, the buoyant effects or the buoyant force. Okay. The buoyant force is more than weight. It pushes up the object up to the surface of water, the object will float. Okay. If the buoyant force is more than weight, buoyant force is more than weight, then it will float, right? Okay. Conversely, when an object is more dense than the liquid, the buoyant force or the upthrust F is less than the weight of the object. It causes the object to submerge to the bottom of the liquid. Okay, this is what happened when the weight of the object is more than the buoyant force, so the object will sink at the bottom of the liquid. Okay, so F here is the force, the buoyant force, and then weight here is the weight of the object. Okay, F is more than, if the force is, buoyant force is more than weight, so it will sink at the bottom, or it will submerge into the water. All right. Okay, next one. Table 8.1 show the density of few materials based on this table. Okay, for example, material 1 is cork. The density is 0.24. Okay, so because it is less than 1, so what happened to the cork when you put on the water? It will float or sink?
Float.
Okay, very good. So it will sink. Okay, water, the what we call the baseline, or the where we start the density at 1 gram per centimeter cube. So this is the density of water. Okay. Glycerin. Now, glycerin is one type of material or one type of liquid that is, it is more dense than water or no? Glycerin 1.26. 1.26? More or less?
More.
It more dense than water, so it will sink or it will float.
Sink.
Glycerin, it will sink. Okay, iron, of course, 7.9, it will sink. Lead, mercury, gold, every object that has the density higher than 1.0 gram per centimeter cube will sink, will submerge in the water. All right, very easy one. This one just a review only, because we already learned this on Form 1, in Form 1. Right? Right. Okay, so Limsoll Line here, if you notice on the boat here, we have what we call a Limsoll Line here. Limsoll Line is the indicator of how heavy the ship. Okay, how heavy the ship. All right. Cargo ship, I just read it for you. Cargo ship marked with Limsoll Line for safety purpose due to the differences in temperature and concentration of salt. The density of seawater is different in different parts of the world. So Limsoll Line will help to determine the safe level for a ship to stay afloat. So this is Limsoll Line. Okay, not every water in the sea is the same, because in some sea the density of the water is different. Okay, the density of water is different. Okay, I just want to ask you, between the fresh water in the river and the salt water in the ocean? Which one has the higher density, you think?
Salt water.
Salt water, right? You see now? Can you see the difference? Although the ship can float, yes, it able to float in either fresh water or the big ship, the cargo ship can float on ocean and also can float on the fresh water in the river. But because of the different density, the level of the ship will sink or float is different due to the different density in the water. So you said that seawater, because there is a salt concentration inside the seawater, what do you think happened to the ship? It will float a little bit or it will sink a bit? If the ship sail on the ocean, what happened to the boat? It will float a bit or sink a bit?
Sink a bit.
It will sink or float a bit? Okay, right. Let me draw it for you first, yeah? Okay, I just try to draw you the ship over here, right? So this is the ship. I just divide it into, all right? One in the fresh water. Or river. River is fresh water, right? And then one is in the ocean. Sea water lah, yeah? Sea water. Right? So this is the water level lah. This is the water level over here. This is the water level. And then also this is also the water level. Same water level, right? Okay? Because of the difference of the density, you said that the ocean, density of the ocean is more than, the density of the ocean is more. The density of the ocean water is more than the fresh water. So what happened to the ship? What happened to the cargo ship? The same cargo ship, okay? The same cargo ship, yeah? I just write it here first. This is the cargo ship lah. Okay, this is the ship. I'm drawing not so good, cargo ship. Cargo ship. A, Z, example. Okay. So, on ocean water, the cargo ship is, the level is like over here. This is the level. Okay, this is what we call Limsoll Line lah, Limsoll Line over here. Okay, and then what happened when the same ship, the same cargo ship AZ, travel into the fresh water? What do you think happened? The cargo ship will float a bit or will sink a bit?
Sink a bit.
Yes, it will be sink a bit. Yeah, because the density of fresh water is what we call less than the seawater. All right, fresh water, for example, in the river, right? So if the same ship over here travel or sail on the fresh water, so this is what happened to the boat. This is what happened to the ship. Same ship. So it will be like this. Okay, it will be like this. Okay, cargo ship AZ. Same same one, same ship. Same ship. All right, and then the Limsoll line will be like this. Okay, can you see the difference here? This is the Limsoll line. This is the indicator over here. This is the indicator if you travel in a river, the safe line will be over here at the top. Cargo ship when sail on the ocean will be at the middle. This is what we call the use of Limsoll line. Okay, go back. I go back to the textbook. What is the indicator here? Okay, for example, this is the indicator over here. TF mean tropical freshwater. F mean freshwater. Do you need to remember this? No need to remember this, class. No need to remember this. But you must understand what are the function of this Limsoll line. No need to memorize. Okay. TF tropical freshwater. Okay, freshwater, tropical zone, summer, winter. Not just the density of the ocean, but also the temperature also. What we call take into account whether the object will float a bit or sink a bit. Okay, so for example here, go back to my picture over here. So if I look, as I zoom back here, I just give it a zoom. So maybe the label here is the TF. TF. And then this is tropical zone, summer, winter, North Atlantic. Freshwater, tropical zone. This is T lah. This is T. And then this is W. Okay. So, TF is tropical freshwater, right? So the ship will sink a bit. This is the safe line lah. This is the safe line. And then for the same cargo ship, the same cargo ship here. This is TF. This is W. And then this is what else? This is what is number 2? T and W. Okay, this is T. And this is W. Okay, based on the line lah, based on the line of the surface of the water, it will determine whether the ship is able to sail on the water safely or not. All right, so this is what we call by the Limsoll line. Is it okay, class?
Yes.
Can, okay. Right. That's why you cannot put too much cargo on the ship when you are traveling on a river. You cannot put the cargo when you're traveling on the river. Okay, what happened? For example, you travel, you put the cargo on, you put much cargo, more cargo when you are traveling on the ocean, and then when it comes to the fresh water, the ship will sink. Okay, because there is much cargo. The cargo is only for sailing on the ocean, not for sailing on the fresh water. Okay, so there is a safety concern. Class, there is a safety concern on the ship. People who know about the ship will know lah. You cannot put too much cargo on different type of water, right? Okay. Okay, Limsoll line finish. Next one. Okay, level I will continue next time. Okay, I will continue level next topic. You have any question, class?
No.
Okay, very good. So if you have no question, you can maybe later on you have question, you can ask on the Telegram group, and then I will give you the extra exercise after the class also. Okay. So I think right now 1:38. I'm sorry for the extra time I take. So you can leave the class now. Thank you for your cooperation. See you all again on tomorrow. Okay, class? Bye-bye.
Thank you,
Thank you,
teacher.
teacher.
Thank you, teacher.
Bye.
Thank you. Thank you. Bye-bye.